Good morning. In the early hours of June 30th, 1908, something exploded over a remote corner of Siberia with enough force to be felt across continents, and to this day, no one has found a crater. For more than a century, the Tunguska Event has stood as one of science's great unsolved cases. Over the next few minutes, I'll take you through the evidence, the leading explanation, and the reason this 100-year-old blast still matters in 2026. Let's begin with what actually happened that morning. Here is the central puzzle in a single image. At 7:14 in the morning, a blinding fireball detonated above the Tunguska region and knocked flat roughly 2,000 square kilometers of forest, an area about the size of a major city. The trees were scorched and splintered, lying in a giant radial pattern. Yet when researchers finally reached the site nearly 2 decades later, there was no crater, no impact pit, and no meteorite waiting for them. The explosion was enormous, but the object that caused it had simply vanished. That absence is what makes Tunguska so haunting. To grasp the scale, consider the energy. Scientists estimate the explosion released about 15 megatons of TNT, roughly 1,000 times the power of the Hiroshima bomb. All of that force was delivered in a fraction of a second, high above the ground. Had it occurred over a city rather than a forest, the human cost would have been staggering. And remember, this happened with no warning at all. Now, before we dig into the science, let me explain why this event from 1908 is still relevant today. The reason Tunguska still matters is simple. Earth remains in a cosmic shooting gallery. The object arrived completely undetected because there were no sky surveys watching for it in 1908. A similar airburst over a populated area today would be catastrophic. That is exactly why the United Nations chose June 30th, the anniversary of Tunguska, as International Asteroid Day. And in 2013, the Chelyabinsk bolide over Russia reminded us that even much smaller objects can shatter windows and injure people. Tunguska is not just history, it is the case study that built modern planetary defense. Understanding Tunguska took a century, and the timeline is worth tracing. The explosion happened in 1908, but it wasn't until 1927 that Leonid Kulik led the first scientific expedition into the site. In the 1950s and 60s, aerial and ground surveys finally mapped the full butterfly-shaped blast zone. The 2013 Chelyabinsk event gave researchers modern data to build far better models. And in 2016, the UN formalized the anniversary as International Asteroid Day. Each generation has added a piece to the puzzle. What Kulik found was genuinely surreal. The trees were not merely fallen. They lay in an unmistakable radial pattern, pointing away from a single central point, as if a giant had stomped in the middle. There was no crater and no large fragments. Eyewitness accounts filled in the human story. A train engineer felt such a violent shock that he stopped his train, convinced it had derailed. The Evenki people who lived there reported the loss of about 1,000 reindeer to the blast and the fires that followed. This blend of physical evidence and testimony is what Kulik used to pinpoint the epicenter. So what actually caused it? The leading explanation today is a meteor airburst, an object that exploded in the atmosphere, never touching the ground. The impactor was most likely a stony asteroid between 50 and 80 meters across, traveling at roughly 55,000 kilometers an hour. It detonated some 5 to 10 kilometers up, where the pressure of the atmosphere shattered it and released its energy as a shock wave. The object itself vaporized, which is precisely why no crater or meteorite was ever found. All the destruction came from the blast wave, not from an impact. But the scientific story is not completely closed. Let me lay out the two main candidates. The Comet hypothesis points to the brilliant noctilucent clouds that glowed over Europe for nights after the blast, possibly vaporized comet ice, and to the total absence of solid fragments. The asteroid hypothesis, favored by modern modeling, argues that a stony body 50 to 80 meters wide best reproduces the treefall pattern and the pressure waves recorded that day. Statistical studies of tens of millions of possible scenarios now lean clearly toward a stony asteroid, but the final word has not been written. Where evidence is thin, imagination rushes in. In fiction, the most famous idea, popularized by Alexander Kazantsev's 1946 story, is that an alien spacecraft crashed or detonated over Tunguska. Scientists have also floated genuinely exotic possibilities: a tiny black hole passing through the Earth, or a fragment of antimatter annihilating on contact. Even as recently as 2009, a Russian researcher claimed a UFO had intercepted the meteorite. To be clear, none of these has meaningful physical support, and simpler theories fit the data far better. But the gap in the record is exactly what keeps these stories alive. So let me leave you with the real takeaway. Tunguska turned a remote forest into a warning. Objects large enough to level a city can cross our path with no notice. It launched more than a century of meteor science, from Kulik's expeditions to today's planetary defense surveys that scan the sky for the next one. The question is no longer whether another Tunguska-scale event will happen, but when, and the work of detecting it in time is the legacy this Siberian mystery left us. Thank you.